So let's go ahead and have our panelists give a brief introduction to themselves. We'll go alphabetical by last name. So starting out with Rachel.
All right, hi, I'm Rachel Akie. I also, like Emily, I work for EarthScope Consortium. I am a cloud software engineer, so a little bit outside the geoscience realm now, but I started in geoscience and I've been in my current position for 6.5 years.
I guess I'm next since I'm B for Bohon. I'm Wendy Bohon. I'm the branch chief of seismic hazards and earthquake engineering at the California Geological Survey, and I've been in that role for a little bit over 2 years. Happy to be here.
Hey everybody, my name is Teresa Butler. I am a geoscientist at ExxonMobil. I've been working here for 3.5 years, and in my current role, I support oil and gas development and production in offshore Angola.
Alex, if you wanted to go next.
Sure. Hey, good morning, everyone. Alex Olsen-Mikitowicz. I'm a remote sensing manager for Colliers Engineering and Design. I am based in Phoenix, Arizona. That's kind of my primary role right now, but I also started a company this year. So I'm the owner for AeroTerra Sensing LLC. I've been in the role at Colliers Engineering for 1 year now.
Hi, everyone. I'm Liam Toney. I'm a research geologist at the U.S. Geological Survey, and specifically, I'm at the Geologic Hazard Science Center, which is in Golden, Colorado. And I've been in my present role since the beginning of 2025.
Great. Thank you for the introduction from everybody. So we're going to start off this panel with this first question, which is, did your career path to your current role include any unique experiences or unexpected turns? And let's hand this over to Wendy first, and then we'll go around the horn.
Yeah, thanks, Emily. I had a very unusual and not straightforward career path, which is an interesting way to do it. So I was actually a theater major in college. Shakespeare is kind of my jam. And I did end up getting a geology major also, but more because I was just interested in it. And because I was getting a BA, I didn't take a lot of the core classes that I would have needed if I was planning on pursuing geology or some kind of geoscience long term. I moved to LA after college because I had an acting opportunity there. And while I was there, I felt the Hector Mine earthquake, which was a magnitude 7.1 out in the desert that was widely felt across Southern California, including by me in my little fourth floor apartment in Hollywood. And after that, I went and started volunteering at the USGS Earthquake Hazards Program in Pasadena and loved it. They hired me pretty quickly to do outreach and education. And then I started going to Pasadena City College to take a lot of the classes that I didn't take in my, undergraduate class situation. So I did that for a long time, 6 or 7 years, and then I went back to grad school and got a master's degree and a PhD in earthquake geology, and that's sort of what led me to where I am today. So from theater into geoscience and research, and from there into science communication, and now back into scientific research and leadership. So.
Let's see. Teresa, did you want to go next with that?
Yeah, sure. So I studied geology in undergrad, and then I got a master's degree in geoscience. And during undergrad, I met with people on a career panel like this and learned about the oil and gas industry, and that's kind of where I got interested. So in grad school, my degree was focused on oil and gas. However, the oil and gas industry can be cyclical with ups and downs. So when I finished graduate school, they were not hiring. So I actually started my career out in environmental consulting. So I did that for 1 year. And then a little bit after COVID was dying down and things were picking back up, that's when I transitioned to my current role at ExxonMobil. So I feel like I learned a lot in my 1 year in environmental consulting, and it was a bit of an unexpected turn that I wasn't initially planning.
Either Alex or Rachel, did you also want to share?
Sure. Yeah. So I guess I was trying to think of my whole path before this, but it was never really like defined, and I got into undergrad and I was like, maybe I'll be an accountant. and had no idea that I would be interested in science. And it wasn't until I took environmental science and geology that I was like, wait, I want to, like, this is way more interesting than something else. So, um, and I probably like many of you, if you're in undergrad, you're like about to graduate and you have no idea like what jobs you can actually get. And undergrad, sometimes they don't prepare you very well for like what you can actually do. I don't know that I attended one of these career panels. So what I ended up doing was like a year and a half or almost 2 years of like just internships right after I graduated, which was really interesting to do. I started out with like GIS and at Oak Ridge National Lab. I had the opportunity to stay there longer, but I was a little bored in it. So I got an internship, like a SULI internship at the National Renewable Energy Lab. In material science. And to this day, I have no idea why I was chosen for that because that was not my major at all. But I was definitely like, I want to move to Colorado. Like, that sounds great. So I just took that. And that program was really geared towards grad school. So it had been something I wasn't really thinking of until then. And then I was like, well, if I am gonna like apply to grad school, I should probably find something more like what I want to do, which is geology. And so I like talked to some people in the geothermal part of the lab and got my second internship there, which were like semester long ones. In that, and that was what kind of drove me to choose my grad program that I went to. And so I did have like one more year to kill because I hadn't planned to go to grad school. So I ended up interning again at Death Valley National Park and did like field work for a few months. And so it was just like a lot of just being open to things and seeing what you really like. And that's kind of like what led me to grad school, where I learned how to code, and eventually to EarthScope, where I'm a software engineer now. So yeah.
Okay, so lots of twists and turns leading up to where I'm at now. I'll talk about one recently, and then probably more twists and turns, unexpected things happening in the future. But during grad school, I had finished all my coursework, and I had worked a little bit as a like drone pilot, remote sensing technician, and I had realized that there was something that I could do to kind of like get further, get a little bit more ahead, separate myself, become more employable, and that was getting an actual pilot's license. So while I was working on my thesis, I was also going to flight school, and I ended up getting my private pilot and my instrument pilot rating. A little bit unnecessarily, but it has come in handy in the past. It gives me a lot of credibility for bidding projects and just on the safety side of operating drones from for this engineering firm. So that is my most recent unexpected twist and turn in my career.
All right, great. Before we move on, Liam will give a chance to answer. If not, no worries, we can go to the next question.
I can go really quick. Just to any of the undergraduates out there, I knew I wanted to do science when I went to undergraduate, but I was a physics major, and I went to a really small school. And sophomore year, we were doing particle physics, and I just wasn't that into it. It was like I couldn't really see what was going on. It felt a little too theoretical to me. And I had a bit of like a sophomore crisis, and I like dropped the class I was in and enrolled in an upper level volcanology course. And the first day we were doing rock identification. I didn't know what was going on there either. So I was sort of like stuck, kind of wavering around. But eventually, sort of as a product of that, realized that I wanted like the research that I do to have a map and to be very applied. And it was an undergraduate internship. Actually, it was the IRIS internship back in the day that I did that was, I credit basically with turning me into a seismologist and kind of getting me onto that track, because the school I went to just didn't have one geophysics course. And so I was already coming in as a scientist undergraduate, but sort of the world of geophysics and earth science was not known to me until later on in undergraduate.
All right, that was great to hear from everybody. Lots of very interesting paths to being the scientists that they are today. So we'll go into our next question, which is a little bit more practical skills based, which is how have you effectively translated the skills you learned into something your employers value? Let's see if you want to start with Alex for a response.
Yeah. Okay. So without getting too much into the nitty gritty, like a lot of the stuff the drone collects is unusable to a lot of the different departments in my company, like at a base level. So what I saw as really important is being able to effectively communicate the important parts and also know how to kind of boil things down to what are people using it for, and giving them kind of that cultivated, curated product. So a lot of statistics, a lot of like decimation, but yeah, like a lot of statistics, a lot of communication, a lot of data communication, because a lot of people just don't have the bandwidth to handle it, and they just want something that's defensible, that they understand, and they can use. So yeah, that makes sense.
All right. Wendy, would you like to share a response?
Sure. Mine is kind of similar to Alex's, actually. I think I have the job I have now because of my communication skills. So, I was saying that I started at the USGS working in outreach and education, and then went back and was doing research. But I did my postdoc in science communication, and then I went to IRIS and did science communication there. And actually, while I was working at IRIS, the California Geological Survey asked me to give a talk to their organization about science communication around earthquakes. And I think that's when I got on the radar of management at CGS. So when the position that I have now came open, they came to me and asked if I would be interested. And one of the things that I do a lot across the organization is handling a lot of the communication and outreach and education. So, in my day to day, I go from the things that I do for the seismic hazards and earthquake engineering program to doing things like reviewing fact sheets on landslides or maps about burned watersheds. And so that communication skill was really critical in advancing my career and the types of positions and opportunities that I was given, because it really doesn't matter how good your ideas are or how good your science is if you can't communicate and explain it to other people. And so that skill set has been really critical, I think, for me. And I'm glad to see that it's really being recognized as a set of skills that can be learned and practiced as well as a field of study. So good stuff. Thanks.
Anyone else who wanted to comment on translating skills effectively? All right, otherwise we'll go on to our next question, which I think a lot of students will find this to be very helpful. So this question is, would a PhD be useful for pursuing your particular role? How does degree level impact scope of work in your organization? And let's see if we start with Rachel for this one.
Should unmute myself. So a PhD is not required for computer science. So here at EarthScope in the data services section, we have people across like a range of degree levels. And typical, I guess, software engineering, computer science, they kind of come straight out of undergrad with a computer science degree. So that's like probably the more traditional path. And then, but our team's pretty diverse, I think, because we are a science organization. So lots of people have masters or PhDs, and you can learn coding along the way. And then you can just show that you've completed projects with modeling and other things. And so you can, as long as you can demonstrate that you have the relevant coding skills, then I think a lot of scientific organizations take on people from a range of degree levels. So, yeah.
I guess we'll ask Liam if you have any insight from the USGS level.
Yeah. So typically at the USGS, there are what we call sort of research grade employees. And then we also have operational positions. And I say typically because this varies depending on which sort of part of the USGS you're within. But the research grade employees usually have a PhD, but not always. The operational folks usually have a master's degree. Um, and I the role of the research grade employees is to sort of pursue original science and write papers, which is something that it's sort of equivalent to what sort of is expected of professors. And so there's, even though the USGS is in academia, I find myself doing a lot of the tasks that a professor would do. So we're reviewing papers, we're convening sessions at conferences, we're serving as editors for journals, that sort of thing. And those skills are skills that I first picked up during my PhD. That being said, we have research scientists on our center who just have a master's degree. And the way that, from a technical level, the way that the USGS defines those research grade roles is based on experience, some combination of experience and education. And so I definitely would encourage folks who are interested in pursuing those roles not to sort of see the lack of a PhD as a barrier to pursuing sort of a research position within the USGS. But as a general rule, from my observation, it does seem like most folks in the research roles do have PhDs.
And then if either Teresa or Wendy wanted to share.
Sure, I'd be happy to share. So at the California Geological Survey, it is not required to have a PhD to work there. In fact, our state geologist doesn't have a PhD or a master's degree. He worked his way up from an engineering geologist entry level and went through all of the different levels, and now he's the state geologist, and he is a fantastic state geologist. We have lots of folks with undergraduate degrees. We have folks with master's degrees. We have folks with PhDs. I think because of the job market at this moment, a lot of the folks we've hired in the last year have come in with PhDs and some with one or two postdocs, so lots of experience, but that's not a requirement. It is, however, a requirement that you get licensed in the state of California to practice geology. So you don't have to have that licensure when you come in, but you have to be able to qualify for it and then be prepared to take that test. So that's a little different than some other states. And that can be kind of more important than your actual degree level. So as long as you meet the qualifications for the job, you are welcome to apply. And we, welcome all kinds of different folks. We have GIS professionals, geoscientists, seismologists, folks that just do data and data products. We have field engineers. There's all kinds of different positions and roles at CGS.
I'll share as well. So at ExxonMobil, for now, for our geoscience, people have either a master's degree or a PhD. I would say a PhD is valued. It's not required. If you have a PhD and you work at ExxonMobil, you do start off with a higher pay and generally a higher career level. All inexperienced new hires will go through the same program. So you do 4 different rotations in your first 6 years. There is more of a generalist track and then a more specialist track. So if you have a PhD and you're really interested in geophysics or something, you might try to put yourself more on a specialist track. But in general, you can move between different roles within the company based on your interests and what the business needs.
Great. So our next question is also a skills-based question, which is, what skills do you recommend that students focus on building before entering the geoscience workforce? And we'll go right back to Teresa to start with this one.
So a few skills. One that's very important is critical thinking. So in my job, we're problem solving, we're solving different operational challenges, and you need to be able to look at a data set and think critically. Another skill would be presentation skills, and with that, the ability to present confidently. So I think Wendy and Alex touched on this a bit earlier, but it's taking complicated ideas and presenting them clearly, maybe simplifying where necessary, and kind of presenting the right level of detail. So I think anything you can do while you're in school to build your presentation skills and build that confidence is really valuable. Another skill would be leadership. So any type of leadership experiences are really valued. And then those fundamental geoscience skills are really valuable. So if you're more of a geophysics student, taking a class, on maybe stratigraphy or something like that, that's not required. That could be really beneficial, especially if you're interested in working in the oil and gas industry.
Alex, did you have any additional insight on skills to build before entering the workforce?
Yeah, sure. This question used to be really easy just from a hard skills standpoint. You could just say like coding and be done with it. But, we've seen that landscape change pretty dramatically the past few years. So I would say like less emphasis on like the nitty gritty coding, but it's still great to understand that enough to be able to wield all these new tools that we have. So I would say like where coding in my realm has kind of taken diminished a little bit as far as importance, I would say statistics and that data communication is filling the void. So why go out and collect all those wonderful data if you can't communicate what they mean, what they're telling you? And that's where statistics is really powerful. So yeah, that's what I'd say about that.
All right, thanks. So our next question is kind of getting into learning a little bit more about what people actually do in their roles. So the question is, can you describe a recent project you worked on? And if either Rachel or Teresa want to go for that one.
I can start. So I guess one of the things I really like about my role is that like here at EarthScope, we like support science. So even though I'm kind of out of the science directly, we do help support it. So I guess an example of that, of a recent project, was we were building new dashboards to monitor the state of health of our GNSS stations. So these stations collect data in real time and are constantly, they're permanent stations and are used a lot in geoscience research. So keeping them running reliably is really important for you guys. And then, so for this project, we set up an application that reaches out to our 1,300 plus permanent GPS stations every hour and collects metrics like battery voltage, satellite tracking, and whether the stations are successfully transmitting data, what files we're downloading. And then we can store that information in a cloud database and visualize it through Grafana dashboards. So if you haven't heard of Grafana before, just give it a quick search and do image search, and you'll see kind of like the dashboards you can set up and all the plots. So this allows our field engineers to easily monitor the station performance and track things like battery degradation over time and decide like when they need to actually go out and visit a site and replace equipment. And so that just really keeps things running. So just keeps the data high quality and continuous for scientists to do the research with.
I can share a little bit too. So in my first role at the company, I was an operations geologist, and I got to support a really cool project in Arkansas where we were drilling appraisal wells to collect lithium brine. So ExxonMobil does oil and gas, but we're also into lithium and carbon sequestration. And so in that role, I got to go to a rig site 3 different times for about a week each time. And I was there for some of our data collection efforts. So we collected hundreds of feet of core data from 2 different wells. And we also did a wireline logging program. So we ran tools downhole to collect data. And that was a really great experience for me because we work with this data in the office. And so to be on site and to see how it was collected and to talk to the people collecting it and make sure it's meeting our standards was really cool. And then we take that data and take those wells to potentially plan a whole development out there. So that was a great project.
Great. Did anyone else have a recent project, either interesting and unique or maybe just kind of mundane part of the job?
There's some cool stuff we've been working on. So at the CGS, one of our mandates is to make maps of active faults. They're called Akie fault maps, and the idea behind them is that we don't want people to build on top of active faults. So we have to identify where they are, determine when the last earthquakes were, right? And we have a lot of new tools that we didn't have. We've been making these maps since the 1970s, but now with things like INSAR, we're able to get a lot more information. And so recently, Austin Elliott at the USGS noticed that some of the INSAR was showing fault creep along the Concord Fault that is in the San Francisco Bay Area. And so the whole team went down there with Austin and other folks from the USGS, and we're out looking at, examples of fault creep, determining how far we should put this on the map. And then, one of our engineering geologists, Danielle, took that project, and now it's becoming part of the Akie fault zone map. So we're, using new technology to update these old maps so that we can help cities, counties, and lead agencies make wise land use choices is one of the things that we do. And it's part of the day-to-day that I really love because it's taking old things and making them better and more useful.
I just thought of one did about 8 months ago with the company I started. So we specialize in using drones, magnetometry to locate orphan and abandoned gas wells. And this project was out in California, actually, for CalGEMS up in Bakersfield. And they had, it's fascinating the way that oil and gas kind of started before things were digitized and stuff. And so the county or the state has a record of a well, written on a cocktail napkin, mapped out, so they go, well, we have record of a well here, but it was cut and, disappeared 50 years ago. So we want to go out and find it. We suspect it may be leaking. It wasn't plugged correctly, et cetera. So drones are really good for this because they can get to a lot of spots that ground-based geophysics can't. So we were flying around all these canyons and stuff that you would never think that, people in the 40s would climb out with donkeys and actually drill a well. But so we were successful at finding some wells in places that when I was flying it, I was like, there's no way there's a well up there. You gotta be crazy. And then the other cool part was we paired a new sensor with this. We used optical gas imaging. We flew this separately. So once we found the well location, then we shot it with a bunch of lasers and figured out whether or not this well was actually leaking detectable amounts of methane or not. So yeah, I'd forgotten about it.
All right. This next question is kind of geared toward our government professionals, Wendy and Liam, but I'm curious if anyone else has a response to this question, which is, to what extent do government policies influence geoscientists' projects?
You want to go first, Liam?
Sure. Yeah. So, the USGS is a federal agency, and so definitely government policies influence what we work on. We are funded annually through Congress, and within the USGS, I work in what's called the Natural Hazards Mission Area. And so what that means is the folks working within that space are all working on stuff that ties back into public safety in some form. And so there's a group working on volcano hazards, and there's a group working on landslide hazards, and there's a group working on earthquake hazards. And there are directives coming down, including laws passed by Congress, that mandate us to do stuff like monitor landslides, reduce risk, etc. And how that translates down into the day-to-day, it means that, whatever you're working on has to have that tie into that application. But that doesn't necessarily mean that all of the work that we do is all applied research. So there are certain cases, or certainly cases, where you're doing basic research on, for example, little micro earthquakes landslides make before they fail. That's a pretty interesting scientific question that's very worth pursuing, that also is very easily cast into sort of downstream benefits for the public. And ultimately, we are public servants. And so the work that we do is going to feed back into public benefit. And certainly that doesn't exclude basic research.
So for us at the state, about a third of the things that we do are mandated. So we have to do those things. And then probably about a third of those things that we do are long-standing projects that aren't mandated, but we do them. So we have, for instance, an essential facilities review team that works with the Department of the State Architect to review schools and hospitals for seismic safety. And that's something that we always do. We're not likely to stop doing that. But that leaves like a third of our time to do other things, like different mapping projects, to do different types of mineral classification reviews, all sorts of stuff. And that's where the different kind of interests of the state and federal government come to us, and we can change direction or change our focus based on that. So for instance, critical minerals has been a big focus of the federal government and subsequently the state government. And so our minerals team has shifted their focus from things that they've worked on more into the critical minerals field. And so being able to sort of flex and move to fit with those priorities is something that we allow some time for, but not at the expense of the mandated work that we have to do.
And fine if the answer is it doesn't really make much impact, but curious on the kind of like the nonprofit or more corporate side, any impact from government policies?
I guess we, like here at EarthScope, went through a big transition ever since I started. So the NSF kind of, we were UNAVCO and IRIS, right, first, and they kind of pushed us to become one. So that was like a big transition. They also pushed us to go to the cloud. So that's how I became from a software engineer to a cloud software engineer. And so some big overarching things have happened, I guess, at EarthScope. I don't know if it's like government policy specific, but government directed. A lot of changes.
So here at ExxonMobil, government policies definitely affect the work that we do. We work both in the US and globally. So outside of the US, we're also looking at government policies of the countries that we're working in. But here in the US, we permit all of our wells. And so that can vary. Most of the permits are going through the state, but sometimes they're federal permits. For CO2 injection wells, a lot of states don't yet have the ability to regulate those. So those would be going through the federal EPA. And so we're always working with the government when we're drilling wells.
Alex, did you wanted to share?
I work mainly in construction and land development, so it's not like I would just say like government fiscal policy definitely has an effect on whether we're building or not. Just interest rates and rebates and stuff like that.
All right, great. So I think our next question is geared a little bit more towards Rachel and Liam. What advice do you have for geology students who are interested in the software side of science?
I guess I can start. I guess it's kind of hard to say, but like just building the real coding skills. So that can come in a variety of ways. Like some people probably even learned like growing up if they were doing something on the computer, they might have learned a little bit. But so if you're an undergrad and like that is your plan, then you can major in like a science degree and you could minor in computer science. There's, I mean, obviously I didn't do that. I took computer science as an undergrad and I hated it at the time. Somehow I ended up, but I think that was because it was, I don't know, I think it was like me and one other woman in the class out of like 35, and I just felt uncomfortable. I didn't know what I was doing. But if you're going to grad school, like I know, at least for geophysics, like it really leans heavily into the software side. You have to like code up to do your research. And so just choosing a product, like a project that's like more model based or data analysis can really help you to learn those skills. I even have a coworker who did an undergrad in astrophysics, but then did a coding boot camp after undergrad and got a job here. So I think there's like a lot of pathways, and you just have to learn it, and then you need to be able to like prove that you do know how to. You've had projects that you can give examples of, and you know the basics to kind of break in. And then I guess certain languages like Python is probably one of the most widely used. I know in some other sciences like R is used, and we had someone come from hydrology masters with our experience, and it's really easy to kind of translate over once you do know a language pretty well. They're all similar in ways and different in some ways, but so I guess that's my advice on software side.
Rachel, I'm glad you're not the only one who hated your undergraduate CS course. I took Java and we were programming Frogger. I
Yeah.
remember that. And then when it came time to do science and programming, I was like, wait, what? How do I do this? Um, but I probably spend half my time per week programming, primarily in Python. I use it a ton. I am a seismologist, and that is just programming is essential to like a lot of the data processing that we do. Um, and so I would definitely encourage students interested in the software side of science to understand also like there's such a thing as a scientific software developer. And so, within the USGS, for example, we have sort of folks that are interested in sort of pure science and don't do much coding. And then we have dedicated software engineers who are working on the real-time earthquake monitoring system that if I was working on that, you wouldn't want that. But there's also something in between. And it's really important to have those people that can speak both languages, if you will. Like they know the science side and they also have, more knowledge on the programming side, especially when it comes to applications and sort of you have this nice scientific finding and you want to, or a method that you've developed, but you want to make it into a tool, making it into a tool that's attractive to use and easy to use and discoverable by the community. So I guess for students specifically, get involved in open source software development. That was a huge thing for me. I got involved in a few projects, and it was really cool to see sort of how the sausage is made and in seismology, if anyone, in the audience has used OBSPY, that's an open source tool that's built by the community. And if OBSPY went away, a lot of things would collapse. And so I think just understanding like the community side of software development, and sort of learning from working with folks that have been doing it for longer, I think is can replace sometimes like a computer science course.
All right, thanks. So some of the prior questions were kind of more geared towards current students. This one is a little bit more towards those who are kind of starting or, in the midst of their early career stages. So this question is, what advice would you give early to mid-career professionals who are still trying to find the right professional fit, especially when many available roles don't feel like a strong match? Alex, did you have anything to start with that?
Yeah, don't wait for the perfect job. Just go out and get stuff. Find out what you don't like. You'll meet people. You'll get exposed to new things. So, yeah, trying to find the perfect fit right out of school doesn't happen.
Any other advice for people who are kind of, in the early stages of their career and still looking for the right thing?
I second what Alex said. Every job that you have teaches you something, and that's all great experience. So I think the setting appropriate expectations is going to be really important. I know people spend a lot of time deciding what they want to do and studying it and have they may have their heart set, but cast a wide net about the things that might be useful or the things that might be interesting. And then take what you can from those jobs. And you don't have to be in a position for a really long time. Like nobody's spending 50 years at a company getting a Rolex and retiring anymore. That's just not really how the job market is working. And so be open to what's out there.
I second what Alex said. Like, get out and meet people. It's great to network. I live in Houston, and here we have the Houston Geological Society, and it's a great way to meet other geoscientists that don't work at my company, that maybe aren't in the oil and gas industry. And I love hearing what they do and hearing what kind of jobs are out there. I know some other cities have geological societies like Denver and Dallas. So I would encourage you to make sure you're trying to meet other people, network, and continue to see what's out there.
All right, so this is our final question before we go into our audience Q&A segment. And this is a very, very practical question, which is your organization hiring right now? Where can I find a job?
So I can start with this one. So yes, ExxonMobil, we are hiring. We do our geoscience recruiting in the early fall. And so for current student and recent grads, there's two primary ways to get your foot in the door for either an internship or a full-time position. So the first one is the AAPG Image Conference, and I'm going to drop a link in the chat. So we have a booth there, and I know other companies also have a booth. Actually, this link did not paste, but I'll just put the name of it. It's called Image. And so, yes, if you go to the conference, you can stop by our booth and talk to the recruiters and give them your resume. And that one is August 17th through 20th this year. It's also a great conference because you can learn more about what's happening in the energy industry. It's focused on geology and geophysics. So I really enjoy going just to hear the technical presentations. And then the second venue that we're hiring at is called the HGS Houston Student Expo. And so that one is September 14th and 15th. And this one's great. There's a lot of companies in the energy industry hiring, and we're looking primarily for master's and PhD students or recent grads from 2023 to present. And so you will bring your resume. There's a optional poster session. I believe there's an optional 3-minute thesis or type of elevator pitch. So that's a really great expo to get your name out, not only to my company, but a lot of other companies based in the Houston area. So I definitely recommend check out one of those events if you're interested.
We are also hiring. So that's just to be clear, like CGS is hiring, and we have another pulse of jobs that are going to come open soon. But the state of California is also hiring, and there's lots of different opportunities at the state that you might not think about. Like the Department of Water Resources has tons of geologists, more geologists actually than California Geological Survey. So there's lots of opportunities, and you can get to those job opportunities through Cal Connects, which I'll put in the chat. Sorry to interrupt you, Emily.
Yes, I was just going to add in, even if your organization isn't hiring right now, I'm curious to know in the current, job market, does your organization frequently hire? Is it kind of, what's the general availability of positions or frequency that you might see postings come up?
Yeah, I can speak to this. As folks are probably aware right now, hiring within the federal government and definitely within the USGS is extremely limited. That being said, I still want to speak to sort of the general advice I'd give to folks, because hopefully this situation will change and we'll be hiring more folks in the future. And the USGS runs a program called the Pathways Internship Program, and this is geared towards undergraduates and graduate students. And in a typical summer, we've had just in our building 30 or 40 plus interns, both undergraduate and graduate, participating in that program. And it's actually how I sort of got my foot in the door with the USGS. I was halfway through graduate school and did a Pathways internship at this building at the center. And those are opportunities that can potentially turn into sort of term employment after graduation. They're also a great way to make connections in graduate school for future postdoc opportunities as well. And so I would encourage folks just to keep that on their radar for when the situation does change. And the spot to look for those positions, as well as permanent positions within the USGS, is always going to be usajobs.gov. So hopefully someone can drop that link in the chat.
And I guess I would say, I mean, Emily might know better than me where we like post our jobs and stuff. But we have a number of jobs. I was just checking right now and I didn't see any like, I guess, extremely relevant ones for the moment, but we hire in education and outreach. We hire in field engineers. We hire data scientists. We hire software engineers. So I think at EarthScope, there's an array of opportunities that come up. I know that we post them on LinkedIn. I've seen that, but maybe Emily can talk a little bit more about like where to follow to see those jobs come up.
Yes, so EarthScope has a specific jobs mailing list, and this mailing list is open to anybody within the geophysics community to post open job opportunities, but that is where all of EarthScope's positions will be posted. You can find anything directly at earthscope.org/careers. I will say EarthScope this year has pretty consistently been hiring, and as Rachel mentioned, we're kind of spread across many different directorates and skill sets. So we've just had a number of hires that are going into our engagement team, which is really education and outreach focused. We're often hiring people who work directly with instrumentation and sensors. So definitely keep an eye out on the jobs mailing list, up for job postings. There you will definitely see things come up throughout the year.
Yeah, from my side, I think my company, we're a national engineering firm. I think we have offices in 25 to 30 states, something like that. If you are a geoscientist who's interested in like more geospatial and surveying, there's tons of jobs. They're always hiring for surveyors. I know that's not really what you went to school for, but what I have seen lately that it's been pretty noticeable is from the engineering and construction side of things. They call it SUE, subsurface utility engineering, and there are definitely a lot of geophysicists employed by these kind of outfits. We use them a lot. We have them in house. We also, subcontract to them. So geophysicists in this meeting, look at subsurface utility engineering.
All right, so I think we're going to move on to our audience Q&A portion. If you've not done so already and have a question, please type that into the Q&A. It can either be directed at a specific panelist if you have a specific interest, or to the panelists as a whole. And we have a number of questions in already. So we'll get started with this first one. So this is a little bit more industry related, which is, in what geoscience subfields, such as mining, oil and gas, environmental monitoring, or hazard assessment, do geomatics engineers find the most opportunities? And it's totally fine if nobody has has the specific domain experience to answer.
Emily, could you tell us, what does a geomatics engineer do?
That is an excellent question. If the person who asked that could put in another Q&A and clarify, we can try our best to get back to that.
I will also admit I had to Google that. And when I Googled it, the summary that I saw was that it encompasses surveying, GIS, LiDAR, photogrammetry, et cetera, et cetera. And though I'm not in industry, I can definitely say that there's quite a few folks in our office with those skill sets. And that's a really valuable skill set. So we work in the landslide hazards realm. We're often sort of getting a really good understanding of topography and where things are located is really, really important. And so we have folks flying drones, doing structure from motion, generating ortho images. And those are pretty specific technical skills that are extremely valuable to a lot of the work that we do.
I think, at least in the oil and gas industry, if you're working for what we call a major company like ExxonMobil, where we're actually drilling, sometimes we'll subcontract different companies to do that data collection part. Something that we work with a lot is seismic data, and we have a geophysical operations team that works to collect that seismic data. So if you can apply those skills to seismic data collection, then I think that they would be very valuable and useful in the oil and gas industry.
All right, thanks. So we'll go on to our next question, which is, a lot of research has gotten interdisciplinary. So for the whole panel, what specific skills or qualifications can one acquire to position yourself at the intersection of most interdisciplinary earth science / geology research projects or job roles?
I would say having GIS experience is really important because that is applicable across many fields. I know Alex was just talking about coding experience and how that landscape is changing really quickly. But I think anything in that intersection of like machine learning and coding and understanding big data can be really helpful because that's something that we find across all or many different geoscience fields. So project management is something that's not specifically a technical skill set, but I think is useful regardless of what kind of role you're looking for and makes you really stand out with other folks.
Yeah, I'll second that, Wendy. I don't personally have one. I'm a big fan of certificates. Like anytime you can get certificates, go get them. But there is a project management professional certificate. If you're specifically like focusing in on working at the intersection, to me, of these interdisciplinary projects of varying scope, like to me, that just screams project management professional.
Great. All right, let's see. Our next question is, how does the career trajectory and opportunities differ for somebody who is really a kind of traditional seismologist or geophysicist compared to a more classical earth science geologist?
I can maybe think on this since my title is research geologist, but for a boring HR technical reason, I really should be called a research geophysicist. And I do primarily seismology. But I think at the places that I have worked at, so I work at the USGS now, but when I was in graduate school, I still sort of worked in the hazard monitoring space with the Alaska Volcano Observatory, which was a very interdisciplinary group of folks sort of volcano geochemists and geodesists looking at how volcanoes deform, and seismologists analyzing the little tremors volcanoes can make before they erupt, and field geologists all working on a common goal. And so there was a lot of sort of researchers kind of working collaboratively. So this kind of gets back to the interdisciplinary question as well. But the job, fast forward to the USGS, the job that I applied to that eventually became my permanent position, it was listed pretty generally. And the folks that got hired into that position, there's a civil engineer, there is a sort of traditional geologist. I'm more of a geophysicist, seismologist, but the survey was looking for people with all of those roles. So it didn't really didn't shut any doors for those people. But I know it might be different in other fields.
Okay, thanks.
I can comment on this one. So, whether you have more geology focused skills or geophysics focused skills, you can have a variety of career paths at ExxonMobil. If you want to stay focused on geophysics, we have a geophysics specialist group here. So, I mean, as an early career, you'll get different rotations. So you'll get to see different things. And then by the time you enter your mid-career, you can kind of decide what you enjoy and where you want to be. We have really excellent training. So if you are coming in with a geophysics background and you want to build more geology skills, you're going to get that training to build those geology skills, or vice versa. If you're coming in with a geology skill set, you're going to get those skills to build your geophysics skill set. So we kind of call all of ourselves geoscientists because at our company, we really want people to know both. So your career can kind of be what you make it, and there's a lot of flexibility here. And it's a large company, and so that's one of the benefits is there are a lot of different roles.
Okay, so let's move on to our next audience question. So this is a little bit more career trajectory related. How often do geoscientists with graduate degrees pivot fields? And what does that pivot normally look like? Or perhaps that isn't encountered and the pivot happens earlier?
I know a lot of people that have pivoted. I'm not sure why. I think it's because it happens often. And a lot of them go, and at least, this is my empirical experience, they go into a related field, right? Like science writing or communication, something along those lines. Although some people take a hard pivot and open bakeries. That's happened. But just because you're not doing something that may be considered traditionally geoscience doesn't mean that the knowledge that you have is lost. And so I think if you have interests that fall outside of kind of what you would consider traditional geoscience, you can explore that and see if it's something that you like. And a lot of times the information that people have gotten from their higher education serves them well in that capacity. Because really what master's degrees and PhDs do is show that you know how to learn and teach you how to learn and execute projects. And so that is experience you can take with you into any field.
Anyone else before we move on to the next question? Okay, so this question is specifically referring to technical skill sets. What skills do you think are there any skills that you didn't have in your early career that made your work difficult or limited your opportunities?
I guess I would say I always felt like, so when I was an undergrad, I was getting an environmental science degree with a geology concentration, and I really wanted to do geology. And so even though I had most of the coursework for a geology degree, I did find it kind of hard to apply to grad school and prove that I want to be a geologist. I didn't have field camp. I feel like that was at that time that was a big deal that you didn't have field camp, which I think may be going away now. But I guess just if you are going to grad school, like aligning with if you know what you want to do, like make sure you have like the uh coursework to get in, and but you can get in otherwise. I mean, I did, so that's just a thought that I had when I was feeling like I wasn't prepared sometimes and trying to apply to grad school.
And I guess I'll also frame this, are having very specific technical skills before you enter a job the most important? Or in many of your roles, are you going to learn or get experience in these technical skills on the job?
I guess I'll just keep talking. For me, like having just like some coding skills and then becoming a software engineer, most of what I've learned on the job. There's a lot more to like making code that's reproducible and maintainable and runs all the time. That's a little different than scientific coding. So for that technical skill, I learned a lot of it on the job.
I think you do learn a lot on the job. So my first job was environmental consulting in Cincinnati, Ohio at Arcadis. And I think almost everything I did for that job, I learned on the job. It just helps to have like a strong foundation, strong attention to detail. For that job, I was doing groundwater sampling, soil sampling, air sampling, and a lot of data collection. And so just making sure that the data that was collected was accurate and things like that. And then in my current role, I've had a lot of training, and so that's been really helpful. So I think, and also have had a lot of great mentors. So when you start a new role, I think your company can teach you a lot, and then finding mentors within your company can be really valuable too.
Okay, great. So this next question is kind of for all of the panelists as well. If you were starting your career again today in geoscience, knowing how the field is evolving, what would you do differently in your first 2 years?
I guess which 2 years?
Maybe, consider it your first 2 years on the job, or either as you're just finishing up school, entering the job market.
I sort of feel like I'm still in my first 2 years, so I won't answer this question.
We can also frame it depending on how long you've been in your position or kind of been within a career. Have there been significant changes within the field over this time frame? Any different considerations for somebody kind of within the job market today versus those who may have been starting positions closer to a decade ago?
I guess I can maybe answer this a little bit because I've seen how this has changed over the past since I started my PhD, for example. And that is, I'm going to bring up the topic of AI, but specifically, there's people using AI to help them do their work, right? So like help them code, for example. And then there's like scientific applications of AI, like training a model to pick earthquake seismic phases. And I think the sort of use of AI to help people do their jobs is like it's kind of everyone is facing that, like it's going to change things, right, in some way or another. But the scientific use cases, that's a direction the field has gone in seismology that I've seen as being, and not just seismology, geophysics in general. I've seen definitely a lot of activity around that, and sort of I do feel a need to stay on top of that. It doesn't necessarily mean altering my research trajectory entirely to utilize those methods, but to understand them and understand the limitations and maybe the benefits, to stay ahead of that, or trying to catch up with that, I guess. So I think that's the single most transformative sort of method that's occurred in the past few years.
I guess like Liam, I was also thinking about AI because I use it every day now in my work, which has been a huge change in the last year. I will say I'm happy I learned how to code before AI because I have seen some people like starting out where they just like kind of get the AI, like prompt the AI to like do stuff. And I don't know if they're really learning like why, whether it's right or wrong. Like I can kind of like get an answer from it and be like, no, that's like a bad way to do it. Like, and you like prompting it, you have to have like that base knowledge to like get kind of on the right path. And so I don't know like if I have advice for that because everything's changing right now. So I don't know if I have advice for like using AI, but like learning a little bit without using it and like getting that skill set there first before you really just like integrate it into your work.
All right, thanks. So this question was touched on a little bit when talking about is a PhD needed? But this person asks, how much priority should be placed on getting experience in the job market and on getting a graduate degree? And they're asking, since it seems like a lot of the panelists and a lot of hires have a graduate degree or higher.
I think it depends on what you want to do. So it's highly variable because there's lots of different roles that you can have in geoscience, and some of them require higher degrees and some of them don't. As far as being competitive, it depends on the organization. If you want to work at the USGS, as Liam said, it leans more academic. And so I think there is a higher value placed on having those graduate degrees. Whereas in areas where you are doing more application work, it may not be as important to have the advanced degrees, and it's more important to have job experience and show that you can function as part of a team and do the work day to day that's needed to get projects past the finish line. And so I think it's kind of dependent on where exactly you want to fall and the type of work that you want to do.
I would just say from the private side, in the current landscape, I think getting job experience would probably trump. I mean, obviously, if you want to be a research scientist, you got to get a PhD. But get that job experience. A lot of companies, a lot of larger companies have education programs. You get the job, the entry level job, and then you can. Typically, you got to work like a year before they open that up to you. But then you can pursue grad school while you are working for that company. So, you can look at.
From my experience in environmental consulting, you do not need a graduate degree. When I started my job, I did have a master's degree, but a lot of my coworkers did not. So it definitely wasn't required. In oil and gas, it can depend, but I think most companies do prefer that you have a graduate degree. And I don't think there's a strong preference between master's or PhD. Usually a master's is enough.
Right. So it kind of seems like it's pretty dependent on where you want to end up. If something is going to be more research tangential, graduate is definitely the way to go. But if it's more consulting, some industry, job skills are and job experience is a little bit more preferred. Okay, so this next question, a simple but fun, interesting question. How much does everyone travel, whether for field work or for meetings, as part of your job? Does everybody sit at their desk, or are we out out in the trenches?
I am literally out in the trenches sometimes. So, but not all that often. I can do field work when it's needed, maybe 3 or 4 times a year, not as much as I would like. And then I go to meetings as needed, usually 3 or 4 times a year.
When I was a remote sensing technician doing a lot of LiDAR mapping, the only time I was home was when I was on PTO. That's kind of what I wanted, but that'll burn you out really fast, I promise you. So right now, in a more managerial role, I travel about once a month, and it's a lot less traveling for specific projects and more traveling for conferences.
My situation is sort of similar to Wendy's. I would say fieldwork's probably about like 2% of my job, but it's a really important 2%. I really enjoy it. And then we have, meetings, academic conferences that we will travel to. I will say the folks that are in operational positions tend to travel quite a bit more, especially sort of in the summer field season.
So for my job, it's primarily office based out of Houston. I would say travel is limited to just a few weeks a year. On one of my prior teams, I traveled to Arkansas for a few weeks to go to the rig site. And in my current role, I'm supporting offshore oil and gas in Angola. So I'll be going to Angola this summer for 2 weeks. And we travel there about once a year on this team.
I guess mine's probably more obvious. I don't get to travel for field work. I wish I could. It was a lot of fun to do in grad school and in my internships. But we usually, like, we're a remote company, so we usually have 2 in-person meetings a year, and then sometimes I'll go to like science conferences as well. So maybe 3 or 4 weeks a year.
Thanks all. So this next question says, it's mainly for Wendy, but if anyone else has advice, please jump in. As someone with an unconventional background, do you have advice on how to best present and utilize your soft skills, both when job hunting and in your role?
Yeah, that's a great question. For me, I think I added the soft skills as another section on my CV, the same way that I had my technical skills. And that way I'm sort of showing that I find this important and highlighting that that's an important part of the work. And I think that the soft skills become apparent in the interview process. And so you want to make sure that those are highlighted. If you have project management experience, communication experience, if you have leadership experience, include those as a prominent part of your CV or your resume. And then when you're in the interview, highlight those, find ways to bring that around and show that you can do these things as well. Because when we're in the hiring process, at least we're looking for the technical skills to ensure that you can do the job. But honestly, a lot of people can do a lot of these jobs. So what sets you apart? And often that's going to be the other skills that you have, which are highly valued in these team environments. Science is a team sport, right? And so you need to be able to work on a team. You need to be able to communicate your findings. If you can manage projects, like that is a huge bonus for us because we have a lot of different projects and we have a lot of deadlines we have to manage. So getting those things out the door, having people that have that experience or that certification, like Alex said, can be really important and give you that extra thing. So highlight them. Don't try and hide them. Just because they're called soft skills doesn't mean that they're not important.
Okay, thanks. So we have a number of questions from students who are international students, either still students or kind of, trying to enter their career. So we'll kind of combine them together. Are there any potential training opportunities for international students? Any ways for international students or those who are not US citizens to get hired within the types of roles that everyone has discussed?
The answer is maybe a bit easier for USGS, which is unfortunately we're not permitted to hire non-US citizens except in very rare circumstances.
Yeah, I'll add that is the same for EarthScope. We cannot sponsor those for work authorization in the United States, but all of our technical courses and training opportunities are available for anybody to join around the world. So if you're more interested in the training and technical skills, those are open, but unfortunately, we cannot provide sponsorship for careers. Teresa?
Yeah, so it's the same here at ExxonMobil. For geoscientists, we're looking for U.S. citizens or people with the right to work in the U.S. But I know that not every oil and gas company is like that, so you could look at other companies potentially.
The state of California is the same.
Maybe for some positive positive answers. Depending on where you are in your geoscience path, if you're planning on attending graduate school, being an international student, that's a really great option that can connect you into the academic sphere where some of those restrictions don't apply. And then on the sort of training side, I feel like the number of these sort of massive online, community organized courses. I'm thinking of materials from the seismology skill building workshop that are available online, that sort of stuff. And I'm sure EarthScope has a list of these somewhere. The sheer volume of material online that's pretty good for training is something to be considered from a sort of skill acquisition standpoint. Something that you can do sort of from your own home anywhere in the world. Yeah.
So this question is kind of another practical question. Where did you learn about internships? We'll also add that to jobs via school, LinkedIn, job boards. Where can you find either student opportunities or career opportunities?
So, I just looked on the internet for a lot of different things. Starting really early in my education, I wanted to get different internship experiences, and I was fortunate to have 3 different ones. So, between my freshman and sophomore year, I did an internship with the Student Conservation Association. So that's going to be a little less geoscience focused and more geared towards like national parks, national forests. But that was honestly a really amazing internship. I was at the Great Smoky Mountains in Tennessee, and I really loved my time there. Between my junior and senior year of undergrad, I interned with NASA out at Ames Research Center in California. So that was a really cool opportunity. NASA does hire some geoscientists for internships, so I would encourage people to look there. They have spring, summer, and fall internships. And then my third internship that I did was with ExxonMobil between my first and second year of graduate school. And the HGS Expo or the Image Conference can be a good way to try to get an internship with ExxonMobil or a different energy company.
I hate to say it, but LinkedIn is a good place. I would recommend checking the EarthScope job board and the job boards that are associated with the different societies like AGU or GSA or SSA, depending on what your home society is, because they do a lot to connect students to opportunities. And being on social media in general can be really helpful in terms of sort of keeping your finger on the pulse of what's going on, because that's an easy way where people will put out internship opportunities, job opportunities, because it doesn't cost anything. So making sure that you're following organizations or companies that you might be interested in working for on social media, because they may be posting job announcements and opportunities there.
I would say, I think the link's been sent now. The EarthScope mailing list is a really great resource, especially when I was in graduate school, sort of, or even in undergraduate. Like a lot of professors will send out posts saying, "Hey, I'm looking for a PhD student or a master's student to study blah or blah," or they'll send out sort of postdoc announcements and sometimes internships as well. And so the mailing lists can be really, and there's more than just the EarthScope one, of course. They can be really, really helpful.
I found that student clubs and organizations were a really great tool for finding opportunities. And then I guess if you're still a student, also professional organizations, there are chapters of geologic societies for every state, and they would be thrilled if students showed up to their meetings, showing interest, looking for opportunities. So don't just stop at the student level. Go attend the professional level ones.
Okay, so we have a little bit more of some specific questions in. We'll see if the panel has some expertise related to this. And this is kind of geared towards technical skills, but they ask, many jobs require experience with specific analytical systems, like a mass spec, ion probe, and have never worked with or had access to those before. How can you make yourself competitive for analytical jobs requiring specific systems if you don't have experience with that? And totally fine if that is kind of outside of the panelists' wheelhouse.
Do you mean like operating specific technical equipment if you don't have access to that equipment?
That's what the question sounds like.
I have no idea. But I would say like a lot of these systems generate digitized data, and there's lots of places where those data are available for free for you to download. Then you can work with and you can get experience working with those data sets. Harvard Dataverse has a ton of open source data. I've even put some of my drone stuff up there to live in perpetuity.
Like, I'm just spitballing here to give some kind of answer, but it could be possible that if you're interested in working with those systems, you could get a job with the companies that make them, like Thermo Fisher or something, and start off in a different position there and tell them you have an interest in learning, how to use the equipment, how to fix the equipment. Like, that's a huge thing. In our, Noble Gas Geochronology lab in grad school, like, people that could fix the machines were almost more important than the people who ran the machines. And so that might be a way to get the foot in the door. And, you never know who might have that kind of equipment around, whether it's a university or, so looking around to see who might run or have that kind of analytical equipment in your area, and then volunteering or trying to get your foot in the door somehow with people could maybe work.
Sorry, I thought of one. A lot of companies and organizations do short courses, demos, workshops. So just going to have to use Google to figure out when they're having them.
Okay, awesome. So this question may also be a little bit or outside or tangential. We'll see what kind of, if there's any helpful responses. What is the scope of startups in the geosciences or atmospheric sciences field? Their background is primarily in atmospheric science. They're looking for something in kind of data visualization, analysis application in geoscience or atmospheric sciences. At least I know EarthScope has a lot of employees who work on the data side and work on producing data visualizations that are sort of tied to atmospheric sciences, like total electron count data that you measure from GNSS stations. However, I'm not particularly familiar what the background experience and knowledge is of the people who are kind of working in those systems.
I'll say I'm not really familiar with any atmospheric science startups. A geoscience startup I am familiar with is Fervo. So that's a geothermal startup, and they've got a few different offices across the country, and I know they do internships, and they've hired seismologists in the past. So that could be a really cool startup to look into if anyone's interested in the geothermal industry.
Okay, we still have time for a few more questions to get through. So not sure if anybody here has completed a postdoc, but say you're kind of more interested in an academia or research realm, how do you find those postdoc opportunities, and what did you consider when picking an institution to do a postdoc at?
Yeah, I can answer this. I think it's important to understand that postdocs can take a lot of different shapes and forms. And some of them might look like a stepping stone to being a professor. Others are going to be maybe in a different setting, like operational setting. And there's sort of, maybe I would say there's kind of two categories. Like one of them would be these like named postdoc programs. So the NASA runs one, the USGS runs one. There's also the NSF postdoc. But then there's also sort of, hey, you did your PhD, you worked with person X, Y, or Z, you talk with them, say, hey, I'd love to work with you. Is there funding? Have you written a proposal that includes funding for a postdoc? And can we work on something together? So that the sort of usual like sort of socializing ideas and like making connections during your PhD to individually work with researchers still applies. But the postdocs can look really different. I think is maybe the thing I would say. But I know Wendy probably has some input too.
There we go. I agree with everything you said, especially the things look different. Like my PhD and my master's degree were quantitative geoscience, and I moved into a science communication postdoc. People that I know that were happiest in their postdocs looked for many of the same things they looked for in a PhD program. Do they like the people they're going to be working with? Is the work that they're going to be doing stimulating? But the difference is that they were trying to do one of two things: either continue on the track that they were on, doing the same kind of work they did for their PhD, kind of closing things out and starting new things, or they were looking to build a different skill set that is adjacent, but would kind of expand their tool belt, whether that's in a particular type of geologic setting or with a particular type of, tool that they're using, like a geochronology tool, something like that. So I think it can take a lot of different forms, but also making sure that it is funded, very important.
I can add on to that. So yeah, second what Wendy had said, that I was looking for either something related to what I was working on for my PhD, but then also something slightly new to try a different set of skills, which I ended up realizing I didn't like that topic that I did for my postdoc, so I kind of went a different direction. But it's more about, do you like the advisor or your mentor you've been working with, and do you like the project? And that's things to consider, like you've done for graduate school. And then also, I was looking for postdocs during the pandemic, so there weren't a lot of academic jobs available. And so I knew I needed a job, and so I went the postdoc route and was trying to see who had funding. And so it really kind of depends on what your interests are. And but when I was searching, it was, I think, Google, or I think I looked at the EarthScope listserv to see, because EarthScope will also post about postdocs as well for like their general job opportunities board, but like the AGU career job opportunities board as well.